Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel higher tier paper from 2018, and this is paper 3, and we're on question 13, which is a question about similar shapes. So what we've been told is that the surface area of shape A to the surface area of shape B is in the ratio 3 to 4, and we're given the volume of shape B and being asked to find the volume of shape A. And we've got to give it in 3 significant figures. So in order to do this question, we need to understand the way that ratios work for volumes, areas and lengths. So first of all, if we've got two shapes that have, and we'll call them A and B in this case, if the ratio of the shapes A and B are in the ratio x to y, so where x and y represent numbers, then the ratio of areas is actually going to be x squared to y squared. And similarly, because volume is measured in cubic units, the ratio of volumes is going to be x cubed to y cubed. So what we're given is the ratio of areas. So if the ratio of areas for A and B is in the ratio 3 to 4, before finding directly the volume ratio, we need to find the length ratio. So we can do that by, to go from square to unit value here, what we need to do is square root both of these. So we could say the ratio of lengths is the square root of the ratio of areas. So that would be, the ratio of lengths would be the square root of 3 to the square root of 4. And we can simplify that. I'm just going to rewrite that here. So the ratio of lengths is going to be root 3. If I decide to work that out as a decimal, 1.732, and I need to make sure I'm using more decimal places or significant figures than I'm required in the answer. So the safest way is just to use all the figures on your calculator and use the answer button wherever possible so that you're not rounding up. Root 4 works out nicely because that's obviously 2, given that 2 squared is 4. So that's the ratio of lengths. Now what we need to do is find the ratio of volumes. So given that if we've got a ratio of lengths which is x to y, the ratio of volumes is x cubed to y cubed, what we then need to do is cube these two values to give us the ratio of volumes. So the ratio of volumes is 1.732058 cubed to 2 cubed. And that works out as 5.1965152 with a few more decimal places after that. But I'm sure that if I've done it to that many decimal places, then that's actually more than 3 significant figures. So the rounding that I've done there wouldn't actually make any difference to the degree of accuracy that's required. So 2 cubed is 8, and it's very useful because that we're given the volume of shape B and being asked to find shape A. It's very useful if we make this side become a 1, because then we can scale up any value of B to find the value of A. But we have to do that by dividing both sides of this ratio by 8. So if I divide that by 8 and I divide that by 8, then what I'll end up with is 0.649519. Okay, and again, I'm doing it accurately enough so that I'm more accurate than the answer requires at the end, so I don't introduce an error. Now, what we're told is volume of shape B is 10 centimeters cubed. So we can make this a 10 on this side just by timesing by 10. So if that's a 10, what we need to do is we need to find then the volume of shape A, which we can do by timesing this side by 10, because we always need to do the same thing to both sides of the ratio. So it's got to give it the same overall value. If I multiply that by 10, I can do that quite easily just by moving the decimal point one place to the right, and that will give me 6.49519. And that's our volume of shape A. The only other thing that we have to do is round that to 3 significant figures. So there's my cutoff point, because that's my first significant figure, second significant figure, third significant figure. What I need to do is look at my fourth significant figure to decide whether I'm going to add one to the 9 or not, or keep it as it is. Now, because the fourth significant figure is a 5, so in other words, it's more than 4, then what I am going to do is add 1 to the 9. So I'm going to get 6. Now, if I add 1 to the 9, it's going to make it a 10. So it's going to go into the next column, 6.50. So there you go. If I add 1 to 49, I get 50. And that is my volume for shape A. And the volume, we would need to give the units as well. So that's going to be in centimeters cubed. And we've done it. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, which is Gary Teaches Maths. And for more help, look at our website, which is just appearing at the top of the screen as we speak. And that is bestmathstutors.co.uk. Thanks for watching.